Sorry. I thought I turned it on when I did the microphone. So now we're going to evaluate. So now this is where the tedious math comes in. You got to, and I always tell students, and I do it today. If you walk into my office, I'm going to put parentheses plus parentheses squared minus 4 times parentheses minus brackets. Why did I put brackets here? It's because of that minus symbol. And I put parentheses cubed over 3 plus parentheses squared minus 4 times parentheses. Just use your imagination. And I'm going to put a 3 here, and a 3 here, and a 3 here, and a 1 here, and a 1 here, and a 1 here. What's 3 to the third power? 27. 27 divided by 9, 3 is 9. 9 plus 9 is 18 minus 12 is 6. 1 cubed over 3 is 1/3. Minus 1/3 plus 1 minus 4 plus 1 minus 4. I'm going to have to use whiteboard next time. I'll have to cut all this out. Of course, we need a common denominator here. So this is 3/3. And this is 12/3. So that's going to be 1 plus 3. 4 minus 12 is 8/3. Negative 8/3. Y'all help me out. And negative 8/3 plus a negative is what? 6 plus 8/3. So that's going to be 18/3 plus, I don't forget what I had over here, 8/3. 8/3 is 26/3. What'd y'all get? Y'all checking my math?
Yeah, I think that's right.
So let's take, I'm going to go ahead and get out of here because I'm going to get a white screen up here where we can actually work some more and y'all can actually see what's going on. I'm not worried about the trigs yet because I haven't even seen where they introduced the trigs yet, but I must have missed it, so we'll go back when I get ready to do the trig. I'm not too worried about the trig because trig is a lot of memorization. I'll just pick some of these out. There we go. So let's do let's go ahead and do number 20. Well, we could do 21 and 22. So do 21 and 22. I'll make it a little bit bigger. There. What I'll start doing, I'll start putting my writing on the right hand side because it writes better on the right hand side anyway. Antiderivative from 0 to 2, 4/5 t to the third minus 3/4 t squared plus 2/5 t. And that really looks terrible. dt. Now, what did I tell you about the constants on these things?
Take them out.
You can take them out. So that's the first thing I would do. I would say 4/5 antiderivative from 0 to 2 of t cubed minus 3/4 antiderivative from 0 to 2 of t squared plus 2/5 antiderivative from 0 to 2 of t, and dt goes in with all those. I don't want Dr. Gabati to get mad at you whenever you take him and you don't put the dt and he marks it wrong. Now you don't have to do this. I'm just showing you that you can break it up into 3 separates and you can pull it out, pull the constant out. That's the way you technically do it, but you could easily just focus on this, and this, and then take the antiderivative and then multiply it by constant. You can do that in your head if you want to. So for those of you that missed the lecture the other day, I'm going to write how to take the antiderivative. 4/5, and then that's going to be parentheses t to the 3 plus 1 over 3 plus 1 minus 3/4 t to the 2 plus 1 over 2 plus 1 plus 2/5 times t to the 1 plus 1 over 1 plus 1, and all that's evaluated at what? 2 and what? 0. That's how you take the antiderivative of a single term, is you take the exponent, add 1, and then take that and put it on the bottom. You want a more mathematical definition, you can look in your book. So, what does that give us? Well, this is going to be 4/5. I'm trying to write my 5s with one motion so they won't do that up there, so I'm trying. T to the 4th. Ooh. Well, that screwed that up. T to the 4th over 4 minus 3/4 t to the 3rd over 3 plus 2/5 t to the 2nd over 2, evaluated at 0 and 2. And what happens with your denominators? 4s cancel, 3s cancel, and the 2s cancel. Okay, did I not hit this thing just a few seconds ago and it worked? Maybe it's the Band-Aid. So that's going to give us t to the 4th over 5 minus t to the third over 4 plus t to the second over 5. And that's evaluated at 0 and 2. Now what does the 0 do? It's going to cancel the whole thing out, so you don't have to put 0 in. Right? So, parentheses, I like that parenthesis. Now I know this is beneath some of y'all because some of y'all will not put parentheses. You'll also cry when you get it wrong. Why do you need parentheses? Well, is that always going to be a positive whole number? No. Sometimes it's going to be a negative, sometimes it's going to be a negative fraction. 2 to the 4th is 16. I think, isn't it? Minus 2 to the 3rd is 8. 2 to the 2nd. Got to have a common denominator of 20. Five going to 24 times 16 is what? 64?
Why did you change that to a plus?
Because I'm just changing the problem as I go. Thank you, Mr. Swanson. That was you.
Yeah.
Thank you. 4 into 25 times 8. 5 into 20, 4 times 4. So 64 minus 40 is 24. 24 minus 16, 8. Which is equal to what? 2/5.
You should have added the 16 instead of subtracting it.
Plus 16, not minus.
What?
You would have subtracted 16 from 24 instead of adding it.
Okay. All right. Let's go back and do it again. Let me just do it myself because I don't know what you're talking about. Let's see. Oh. Y'all think I'm going to lose it before the class is over?
There's a chance.
Hmm?
There's a chance.
I think y'all already would have lost it. What do you think?
We can just stop and watch the debate.
Y'all wouldn't watch it. Y'all don't care. 64 minus 40 is 24. 24 plus is 40. Thank you. 40 over 20 is... Oh, wait a minute. We need a calculator.
Yep.
What's this 6 cents for? 2. Now, let me ask you a question. Where do students get the problem wrong?
Where you did.
Right here. Why do they get it wrong? Because they can't do basic math. Oh, I'm sorry if I offended anybody. No, I'm not. You can't do basic math. You can't do, what, 5th grade math. People wonder why people can't make change at the cash register. I love to mess with people at the cash register, especially when I know they don't know what they're doing. Give them like 27 cents. And you see that it close.
If you give them the money and then give them change.
Yeah.
Change.
And they what's this 27 cents for? Idiot. Okay. Let's do an order. I think I told you I'll do the next one. Whichever one that one was. Wish I could put this thing somewhere. Well, I could put it in the upper right hand, left hand corner and have plenty of room, but I'd hear a lot of bitching, so if I did that. So there you go. Do 22. Now what's wrong with 22? It's not written. I don't know why they do that. And people say they're just doing it to test the students. No, they're not. They're doing it to aggravate the teachers. Is what they're doing. Oh, I hate when they do that.
Yeah, it's the way like all the homework is. It's all backwards.
If they keep it consistent.
Oh no, these are engineers. You are stupid. Gosh, don't you know that? I didn't just do that. Today, it sucks.
Sounds like you should just quit.
I think I should. I just really should. What's your fault? You know who I want to beat up? The two people that came up with the hand blowers in the restrooms, and the one that come up with the motion censored paper towel cleanse. They should be shot.
They were probably engineers.
Huh?
Probably engineers.
Do y'all use those? I don't use the blower things. I think they're stupid.
You can get your hands dry just as quickly as shaking them up.
I know. Y'all should have watched the debate last night. They really jumped on the moderators. They jumped on them big time. Should have watched it, but y'all don't care.
I'll watch it when I get home.
Yeah. Well, at least you recorded it. Just vote for Hillary. That's who the media wants you to vote for. So just vote for Hillary.
What was it on?
Huh?
What was the debate on?
Economics. You think they asked Trump or Fiorina anything? No. Asked them about tiddlywinks. Two CEOs and they don't even ask them an economic question.
Because they know they'll sound the best.
Exactly. And that's what the media don't want you to vote for them because they're doing good. They want you to vote for the sorry politicians that don't know what they're doing because that way Hillary has a better chance of winning. Antiderivative from 0 to 1 of 16 v to the 7th minus 8 v cubed plus 1 v whatever. And if you want to do it by the book, 16 antiderivative from 0 to 1 of v to the 7th dv minus 8 antiderivative from 0 to 1 v to the 3rd dv plus antiderivative 0 to 1 of dv. Now I'm writing it like this because pull the 1 out. You need to get used to seeing this because sometimes when y'all see this, y'all just stare at it. Okay, so anytime you take the antiderivative of dv, it's going to be d. Or antiderivative of dx, it's going to be what? X. Or dy is going to be y. And sometimes they will put in the test or the homework, they'll just put this. And some of y'all will sit there and stare at it for 2 or 3 hours and don't know what to do. So I'm just showing you that. That's a problem for some students, especially first time seeing calculus. So 16, d to the 8th over what? Over 8. Of course, this is 16 over 1, so that 8's going to cancel. Hold on a minute. I have to hit it 5 times. Okay, did I not hit that eraser? Did I not hit that? Maybe I shouldn't have calibrated it.
Hit the small one.
Did I not hit that same spot 5 or 6 times? Okay, that's all right. Don't give me any encouragement. I appreciate it. Don't give me any reinforcement. I don't need it.
Yes, it is.
Thank you, Mr. Schaller. I appreciate it. Just forget it. I'll just go on with the problem. Okay, you're supposed to go away. Did I say I was going to lose it? Now we just...
I think you might be better off using the whiteboard.
Yeah. Do a calculus problem on that? No. Don't think so. I know what you're saying, but no.
We might get through it quicker.
No, I just don't want to write 5,000 times and erase 5,000 times. I really don't want to do that. I'd rather deal with this, even though it's very challenging. Somebody give me the problem again. I don't feel like doing all that other stuff. Antiderivative of what? 0 to 1.
Parentheses.
16b to the 7th
16, what? V to the 7th?
minus 8b to the 3rd
8V to the 3rd
plus 1.
plus 1dV. I'm just going to go ahead and do it. So, antiderivative, or no, I'm not going to do that. Just forget that. I'm not going to worry about it. So that'd be 16 over 1, V to the 8 over 8, minus 8 over 1, V to the 4th over 4, plus 1 over 1, V over 1. Evaluated at 0 and 1. So you can go through and skip some steps if you want to. 16 and the 8, 2, 8 and the 4, 2, and the 1s cancel. And you get 2 V to the 8 minus 2 V to the 4th plus V evaluated at 0 and 1. Now you can't cancel, well you can cancel out the 0, but the 1 be 2 times 1 minus 2 times 1 plus 1, and your answer is 1. Y'all check me.
You're in.
$24. And I know some of y'all that have had calculus is bored out of your mind, I know, but I'm not teaching you. I'm teaching the people that have not had calculus, so I don't really care about what you think.
Is that 1 and 6?
What?
1 and 6?
1 and 8. X to the negative 2/3. Now can you do this two different ways? Yes, you can do it two different ways. You can make x to the negative 2/3. You can make that over 1. I would not do that because that's just more work, but you can do it that way. Zero to 8, x to the negative 2/3 dx. Is it 0 to 8 or 1 to 8? 1 to 8? I'm not going to erase it because we don't have an eraser, I guess, on this today. So, that's going to be x to the negative 2/3, and then we just stare at it for a while. Right? Or add 3/3 over negative 2/3 plus 3/3, or just sit there and stare at it. Because now you're supposed to say, where did 3/3 come from? I have no idea. I just pulled it out of the air. Where did 3/3 come from? Well, I told you you add 1 to the numerator, to the thank you, the exponent, and then you take that number and put it down here. I still don't understand. Okay, we'll just forget it. X to the 1/3 over what? 1/3, and you divide by a fraction, you multiply by the reciprocal, so the antiderivative is 3x to the 1/3 power. So now we take 3x to the 1/3 power and evaluate it at 1 and 8. We're going to have to work on this one, Miss Anthony. Why?
A fraction exponent.
No, we got numbers instead of zeros. Such a disappointment. So 3, you only got to do 1.
I don't know what
Yeah. 3 parentheses 1/3 minus 3 parentheses 1/3, and 8 goes here and a 1 goes here. What is this? Exponent over what? Index. So let's write it so we can see what's going on. Cube root of 8 minus 3 cube root of 1. And see, that's a whole lot easier to see than the 1/3. And what's the cube root of 8? 2. And I'll do this one. Cube root of 1 is 1. You're welcome. And what's 6 minus 3?
3.
And you feel good about yourself. You can make these up all day. You can find them all over the place. So practice them. At least 8,000. Okay, now we can't get it to this thing. I shouldn't have calibrated it.
It's going to freeze up and not do anything.
Eventually, probably will. All right, let me get out of this. Like I say, it kind of would help if they had given us some training before the first day of class, and they still keep putting off the training, so I guess we're just not going to have it. Maybe a couple of semesters from now we'll have it,
When they have a new system already.
when they have a new system. Indefinite. These are the ones that I told you about as far as the opposite of definite. These are just when you take the derivative of something, the antiderivative. There's your trigonometric functions right there. So this is page 403. So I'll blow that up. Well, I'll just do it on here. And you might want to write some of those down. This one right here is telling you that you can pull the what out? A constant. This one right here is telling you that you can break up a positive or a negative. You can break it up into two separate. We've already done that this morning. This one right here, the derivative of any number is that number times x, or that number times whatever. If this was k dv, then it would be kv. If it was k dy, this would be ky. If this was k dc, this would be kc. So anytime you take the antiderivative of a constant, it's going to be that constant with the variable in respect to this. And here's the rule we just finished right here, which is your basic of the basic of the basic integration rules. Basically, power rule. Right there. Write this one down. This is going to, in Calc 2 and Calc 3, they use e to the x a lot, mainly because in some of your integration and derivative rules, some of your more advanced, you take the easiest thing to take the antiderivative or the derivative of. And what is the easiest thing besides 1 or x to take the derivative or the antiderivative of? E to the x, because the derivative and the antiderivative of e to the x is e to the x. So you're going to see e to the x a good bit in Calc 2 and Calc 3. So remember, the antiderivative of e to the x is e to the x. The derivative of e to the x is e to the x. And your dang old rules here. This one's important. You'll see that one a lot. You'll see these two a good bit. I'm sorry, what?
What's the one with the right under the-
This one, fractional exponent, a variable exponent. Remember the change base formula in logarithms?
Yes.
If log base 2 of 4 is equal to log of 4 over log of 2, well, this is kind of the same thing. If you have b to the x, or you have c to the x, or d to the x, that's going to be d to the x over the natural log of d. Yeah. Or b to the x over the natural log of d. There is no calculating the antiderivative. These three right here, just like the trigonometric, are all what? Memorization. Where this one is what? Mathematical. So these are all memorization. So you need to, you need to put this to memory